barge is being towed at 16 feet per second when the tow line breaks. It continues thereafter in a straight line but slows down at a rate proportional to the square root of its instantaneous velocity. If 2 minutes after the tow line breaks, the velocity of the barge is observed to be 9 feet per second, how far does it move before it comes to rest or when the velocity is equal to 0? When p is equal to 0, our velocity with respect to time is 16 feet per second. Since the barge is slowing down, so our rate is equal to negative k square root of v. After 2 minutes or 120 seconds, the rate of the barge has slowed down to 9 feet per second. So we are to find the distance traveled by the barge before it comes to rest. So we begin with the rate of deceleration of the barge. We separate the variables v and t, so dv over square root of v is equal to negative k dt. We integrate both sides. Integral of dv square root of v is equal to 2 square root of v, and integral of negative k dt is negative kt plus c. So we divide both sides by 1/2. That is square root of v equal to negative kt or c minus kt all over 2. Squaring both sides, we obtain c minus kt over 2 squared. Now, we substitute v is equal to 16 feet per second when time is equal to 0 seconds into the equation. So 16 is equal to c minus k times 0 all over 2 squared. So this becomes c over 2 squared. Taking the square root of both sides, we have 4 is equal to c over 2. So our c has a value of 8. Now, we substitute the value of c to our equation 3. So v is equal to 8 minus kt all over 2 squared. To find the value of k, we substitute v is equal to 9 feet per second at 120 seconds. So 9 is equal to 8 minus k times 120 all over 2 squared. Taking the square root of both sides, we have so k is equal to 1 over 60. Substituting the value of k to our function, we have 8 minus t over 60 all over 2 squared. So v is equal to 4 minus t over 120 squared. Expanding our function, we have 16 minus t over 15 plus t squared over 14,400. This is now our v function of t. Velocity is equal to distance over time, so we can equate this equation to ds over dt. Transferring dt to the other side, we obtain Now we integrate, so s is equal to 16t minus t squared over 30 plus t cubed over 42,200 plus c. The distance to be considered starts at the point where the tow line broke. That is, at time 0 seconds, the distance traveled is also 0. Substitute 0 to s to find the value of c. So, c is equal to 0. Now, we have to find at what time will the velocity of the barge be equal to 0. We can now solve for the distance at time is equal to 480 seconds. Therefore, the barge had traveled 2,560 feet before it comes to rest.